All right, let's dive in. We're going to crack the code on the most fundamental language of every computer out there, binary. Yeah, it just looks like a bunch of ones and zeros, right? But stick with me, and by the end of this, you'll be reading it like a pro. Let's do this.
So check this out. On the left, you've got the number 28. Simple enough. We see that every day. But on the right, we've got 1, 1, 1, 0, 0. I mean, they couldn't look more different, could they? But here's the crazy part. They're the exact same number. Seriously.
So, how, right? How on earth do we translate that string of ones and zeros into a number that actually makes sense to us? Well, that's the puzzle we're about to solve together. And trust me, it's way easier than you might think.
The whole secret, the key to all of this, is a concept you already use every single day. It's called place value. You might not even realize you're using it, but you are, every time you look at a normal number.
Okay, this chart lays it all out. In our normal number system, base 10, every spot has a value. You've got the ones place, the tens place, the hundreds, and so on. They're all powers of 10. Now look at binary. It follows the exact same rule, but instead of powers of 10, it uses powers of 2. So you start with the ones place, then you double it to get the twos place, double that for the fours, then eights, you get the picture. It's the same system, just a different foundation.
All right, theory's over. Let's put this into practice. We're going to go back to that number from the beginning, 11100, and translate it together step by step. Here's our 4-step recipe for success. It's super simple. First, we write down the binary number. Second, we line up the place values underneath it. Third, we do a quick multiplication. And fourth, we just add up the results. That's it. Let's get to it. Okay, so here we go. You can see we've written out our binary number, 11100. Now, for the important part, we work from right to left. So the first spot on the right is the ones place. The next one over is the twos, then the fours, the eights, and finally the 16s place. You see that pattern, right? Each spot is just double the one before it. Now for step 3, the multiplication. And honestly, this is the easiest part. Just think of the ones and zeros as on-off switches. If you see a 1, that place value is on. We keep it. If you see a 0, that switch is off. We just toss that value out. Simple as that. And here's what that looks like. The 16s, 8s, and 4s places all have a 1, so those switches are on. We're keeping those numbers. But the 2s and 1s places have a 0, so they're off. We can just forget about them. They contribute nothing. We're at the home stretch. The last step is just to add up all the values we kept. So we're just going to do 16 plus 8 plus 4. And what does that give us? Boom, 28, right back where we started. See? The code is cracked. It's not some kind of computer magic, it's just counting in a different way, all based on that one simple idea of place value. Awesome. You've got the hang of it now. So let's do one more just to really lock it in. We'll go with a slightly bigger number this time, 101101. Okay, same process. We'll just move a little quicker this time. We lay out the number, and we fill in our place values from right to left. 1, 2, 4, 8, 16, and this time we need the 32's place. Now, which switches are on? We've got a 1 for 32, 8, 4, and 1. The rest are off. You know the drill. Let's just add up the on values. 32 plus 8 plus 4 plus 1. And that gives us 45. And there you have it. The process is exactly the same whether the number is 5 digits long or 50. It never changes. Okay, so you can read binary now, which is cool, right? But you might be wondering, why does this actually matter? Well, it matters because this incredibly simple system of on and off, of ones and zeros, is literally the foundation of our entire digital world. So let's boil it all down to a super simple 3-step guide. Step 1, list out your place values, 1, 2, 4, 8, and so on. Step 2, only keep the place values that have a 1 sitting on top of them. And step 3, add those keepers together. That's it. That's the whole game. And this really brings home why this is so huge. Every single time you click your mouse, every photo you scroll past on your phone, every song you listen to, it's all being processed and stored using this simple math. It is the absolute bedrock of modern life. So, you've just learned the native language of computers. You've taken your first real step into understanding how they actually think. Which just leaves one big question. Now that you can read their language, what are you going to understand next?
Thanks for tuning in.